Hello and welcome. Today, damn it. I thought I had this pulled up. Today we're going to continue working on the basic interpreter that we've been working on for a little while. At this point, we have, I guess we have Lexing. I don't know if you could hear that, but that was some lightning, like really, really close. That's kind of terrifying. If the stream cuts out unexpectedly, I'm getting a really heavy thunderstorm right now, so might just lose power. But for now, we're vibing. Yeah. So what we have right now is we've got lexing, parsing, and then we've got some of the more basic interpreting. So we've got expressions are being interpreted, and that's pretty much it. I think variables are being assigned too. You see we get 0 here because of this print. But as of right now, this like if statement and this go-to are being ignored. So let's get on that then. So this this isn't the basic. This is effectively just the AST. This is running the foo.bas program, which is here. And you can kind of see that this program parses into this tree. So you've got A equals 0, B equals 1, which is A equals 0, B equals 1. Then you've got this condition and so on. And so right now we're walking each of these lines and we're parsing them. I really hope that that sound is not all messing with my audio, or that the thunder is not messing with my audio, but hopefully it's not too bad. Yeah, so okay, we've got this. Let's go to our evaluation, and I guess let's go to the eval.c. And inside of this if statement, inside of this case where we actually go over each of the branches, let's also do a default. We don't have unreachable. Assert 0 and unreachable. Reachable. Oh my god, typing is not a thing today. Okay, and this will just make sure we error if we hit this branch, which means that we just have some memory corruption where somehow the kind is set to a value that's not valid. And because in C, enums are just integers, that's possible. Like, actually, you might even... Is it okay to do this in C? Yeah, there's no, like, warning for that, which is kind of scary. But yeah, okay, so then if we get one that we don't know, let's say to do if AST, to do go to AST, to do end AST. And at the moment we only have a super tiny subset of these supported operations by basic. If I pull up, got this AppleSoft basic reference, it's significantly larger, but we're skipping a whole lot of this just for the pure purpose of getting something working. Then we can do clear AST. So now when we run it, we should panic, or have an crash the program effectively at this if. And I guess now is a good of time as any to do the if. I do wonder for if it is just any statement, so we're gonna have to evaluate that correctly, but that should be fine. So for an if, we need to evaluate the expression, because an if holds on to so if.value.if.condition, and then it puts it into value. Label fuck off, like that. And then here we're gonna just use value minus, or I guess value dot we can assert for now. No, you know what? We can even be super fancy and say if value kind is VK. Wait. Oh, can we not hold strings at the moment? I don't think we have strings at the moment. So we're just gonna pretend like it's always gonna be a number. Or, yeah, we're just gonna assume it's always a number for now. And we can say value dot value dot number is a double. And then if n less than, or sorry, n minus 1. And then we have abs f, or is it fabs? Include math.h. I'm pretty sure in our makefile we're already linking with math. And we come back down here. If it's less than 1e minus 6, then we're going to assume that the value is 1. Or I guess we don't even, no, let's do an opposite. So if it's greater than or equal to that, then we just assume that the value is true. Right, so this basically checks if this is equal to 0, or if this is greater than 0. Right, you can generally replace that with 0 in floating point operations. And we just need to use effectively this epsilon here just to make sure that we don't have any like weird rounding errors. But then we can say eval expr. Is that, no, that's not quite right. We need to eval, I guess, AST. What is AST value if statement is an AST? It's an AST star. That should be fine. So we say eval AST VM this guy. And then line set. What is that variable? Oh, that's if we set the line. So we just need to pass that through by reference. No, not by reference. Right. That seems correct. We also want to say if this return 1, and that's just how we're handling errors. If statements, do they have an else? I don't think they do. So we don't even need to worry about that. It's been a little while since we wrote this code and I've kind of forgotten a lot of it, but yeah, this should be fine. So if our value is something, then we're going to evaluate that statement. And if we run this to do goto. Okay, so now let's implement goto. So goto, or AST value goto line, just hold the line. And so here is going to be a little bit weird. We need to say VM dot current line, or I guess first of all we need to figure out which line. So size t next line. And then we're going to say for size t I equals 0, and let's set this to -1. I is less than, this is going to be the VMs, I guess the lines that it has, and the count of those. And then if VM lines items at I, so the current item, if its line is next line, not next line, sorry, if it's AST value go to line, so if it's the line that we're trying to go to, then we're gonna say next line. What is, wait, so next line is I guess so we need to set the current line. What does current line actually end up being? So eval line, if line set, then we do this. Does current line, is that like an index? Eval does this. So no, current line is not an index. Hold on. Sorry. Okay, yeah, sorry. Current line is not being used as an index here. Oh. Okay, then never mind. We don't even need to do this. It's literally just going to be VM. Current line is AST value go to line. And that's it. Ooh. Okay, so something is a little bit wrong. Wow, that's printed a lot. So it's actually 0, 1, 1, 2, 3, 5, 8. So all of that is correct. Does end... This didn't ever do this to do, which is interesting. If we do head like N100. Yeah, so this is just counting. And counting. And counting, holy shit. I don't know how big. 2,000. There we go. So we do get to infinity. But that is a little bit weird because let's see, foo baz. We should hit this point where if a is greater than 100, then we're gonna end. Let's see. So in eval expr, do we do this correctly? Eval op says if it's greater than, value number is this. Does that work in C? If I did int main, one is less than 2, and include standard IO, and we printf this. What do we get? So we do get 1, and then we do get 0. Okay, that seems fine. Let's do this. Do we have debug macro? We do. And this is going to be if condition. And it's going to evaluate to n. Format specifies unsigned long but has type double. Correct. And we don't even need to go through all those. We can say 100. We can say 50. We can say 25. And it's not printing anything at all. Really? What does the debug macro even do? Do that. So it should definitely print something. Oh, but it's putting it into standard error. Okay, yeah, so if condition 0 there. Which okay, I guess it showed that above too. It's a little bit annoying because I want... Yeah, okay, this is fine. So, Our condition is getting 0, which means that we're not going to end typing. Right, because if we get something greater than 0, then we do the actual statement. But our condition is always our condition is only being run once. Is our go-to working? Yeah, it has to be working because we're looping. Okay, interesting. Current line. So in our go-to, we set you know what? Let's do this. Let's print f our current line. And current line is actually, I thought current line was a size T, or an S size T. Oh, no, we do end by setting a variable, so never mind. Yeah, so, okay, let's do this. And a new line, because we're cool people. Okay, so current line is 10. I agree. Then it goes to 20. I agree. Then it goes to 30, and we print. Then 40, 50, 60, and then 30. Which means, oh, okay, yeah, so go to, this guy also needs to say line set is true. Okay, well now we get no standard output. Oh. That was weird. I think this is doing what we want. Okay, let's remove that printf. Let's remove that debug. Yeah. Okay, so we get 0, 1, 1, 2, 3, 5, 8, 13, blah, blah, blah. That's the same thing that we get when we do BW basic. 0, 1, 2, 3, blah, 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 all the way to 89. Okay, cool. And then now we fail at end. And end should actually be as simple as saying VM stopped is true. And then we don't really care about anything else. Okay. So I guess we have an interpreter for Fibonacci numbers. That is, that's cool. So clear, as I understand, this is another expression that we added, but don't actually use. Yeah, it literally just clears all variables. That should be fairly simple. We say VM vars count is 0. Actually, that should be everything that we need for that. And we can actually test that, I guess. We've got a few basic. We've got this bar, which actually does functions, but we're going to hold off on those. So if we do 20 print A, right now, if we do bar bas, you get print 5. Okay, and then if we do clear, you get undefined variable. And that's the same behavior as BW basic, if I'm correct. No, you get 0. Oh, that's interesting. Is that just the default? Oh, that's kind of weird, but okay. Yeah, that's kind of awful, but that's fine, I guess. Where do we say undefined variable? Yeah, so if we get nothing, actually, if we get nothing, we just leave it as is and var stays 0. Yep. Okay, so that's cool. What else? I think that's basically everything we had, like that we're parsing at this point. Do we have any more to do? No. Do we have any more to do in the project? We've got a few. Oh no, those are the, what? I don't need all this Git stuff. Okay, so definitions, yeah, who cares? To do rest of tokens, yeah. Dim, def, and go sub. None of which are super important at this point. Okay, what else do we have? So we don't have subroutines yet as a concept, and I don't want to what's the word? Implement those quite yet. So we're gonna hold off on that for a minute. Let's see. I want to make sure that we can handle this case where we use if go to. So let's see. In bar, or I guess in foo. Let's say go to 70, and then down here we'll literally just say end, and that is in foo. Okay, so that is an infinite loop again, which is interesting. Unexpected token numlet 70. Also, why did that not fail? In the main, if we have a parsing error, we should definitely fail. Print parse AST, not that. It's gonna be in here. Okay, so if parse line return 1. Yeah, there we go. Okay, so unexpected token numlet 70. Right. If we go to our parse, where do we parse our if statements? Here, token kind if, condition, we do all of this. Right, okay, so we're gonna pop this token. And then we'll, if it is a go-to, then, so here we're gonna parse a statement, but if it's go-to, then we don't want to parse a statement. Although, you know what? We can just keep storing that as a statement, where the statement kind is a go-to. And I think that would just be the easiest. So then we can say if go-to, then we're gonna do this. Like that. And then here we're gonna say if, or I guess DA pop tokens. And this is going to be a token line. If line kind is not TK number, numlet, then here we're going to error. How are we doing errors? Okay. And then we can basically just copy this logic. Like that, and then we can say statement kind is what is it, AK go to, and statement value go to is going to be line, assigning to size t. Yeah, line dot value dot number. Yeah. And we can even size t that if we want to be super duper precise. Okay, so that seems to still be working, and it says then go to 70. Okay. That's cool. Yeah, to be honest, I was not expecting to finish running that so quickly. So I'm a little bit out of thought there. Here. What? Something. Sorry, I'm losing my mind. Okay, so I don't really want to do any of the more display items yet because that's going to be a little bit weird. Or not weird, it's just going to take a little bit more thought. We could do strings. Like right now we can't, if I go back to bar, we can't do like print hello. Go a bar. We can't do that because it doesn't know how to do the quotes. But also, I don't really know how strings should be handled. Like, I don't know if they're considered a value, and I don't know what happens when you try to add strings and stuff like that. So I kind of want to hold off on those a little bit until I get a better understanding of the language. Let's do comments, because we don't currently support those. But you should be able to say rem, this comment is ignored. This would be unexpected token rem. Okay. So yeah, let's do that. So that's short for like remark, I think. Same kind of thing as what's it called? Batch programming, like for command prompt in Windows. There's a lot of not implemented cassette tapes. Okay, yeah. So let's do where was it? Rem. Maybe we even do like trace mode because why not? Okay, so that is going to be part of the Lexer needs to parse the rem token. Where do we define tokens? Where do we define tokens? Text tokens. Oh, it's probably in here. Yes. Okay, so text tokens is also going to include rem. And I guess that just kind of handles that. Or not. Does the makefile actually... should do that. TK-rem is not handled in Switch. In line 108. This guy. So what do we do if we hit this? So this is for evaluation. We should never hit this. Or TK-rem. Okay. We got sig abort. Great. Parse.c line 148. Right, so that's this guy. If we get TK rem, what is the context of this? This is probably parse line, parse statement. I guess if we get this, then we just return 0. We don't even do anything with it. Although that's weird. We need to say out is null, I think. Although that's not going to do anything. Let's do a special value here. If, I guess 1 means error, 0 means okay, -1 means ignore. Statement. There we go. Cool. So now we can come down to, where do we call this function? Yeah, so if, oh, this is going to be weird. This is for if parse statement. You know what? No, let's undo that. I think we can just assert that rem can't happen in here. Unreachable. Rem can't occur in a statement. And I think that's fine to do, because then whenever we parse like a line here, if line items at 0, I think items is the token array, dot kind is tk rem, then we're just going to continue and just kind of skip that line. What happens if we go back to bar? You can't do x plus 1 or x equals 1 or something like that here. So yeah. So yeah, I think that's fine to do. If we do that, then rem can't occur in a statement failed. That's cool. That's interesting. How does that happen? So we parse statement. Let's do this, and then we can just debug rem. So that never happens. That's interesting. And this is also technically like if the what am I saying? If the items only has or if items is empty, then that would fail. Okay, so parse statement it's a weird function because like it just does nothing. Let's see, here's something else. If I go here, can I go to 20? I can. Versus if that line wasn't there, you would get an error. So you know what? In that case, let's actually parse it properly. And instead of just asserting, we're going to say out kind is ak empty. And that's basically everything. And then we can go define ak empty to literally just be an empty statement. And then here we can just say empty. Yeah. And then we probably have an error somewhere else, or a warning somewhere else. Or not. Parse.c line 150. Invalid token kind. Right, this needs to break. Unexpected ident this. That's interesting. Oh, right. We need to actually clear the tokens. Basically, we need to consume all of the tokens, and we can do that by just setting the length to 0. So now line 20 is just an empty expression. And if we go back to our bar, in 30 we go to rem, or go to 20, then we just get that to go. Invalid line number 10. What? Where is line number 10 set? Is that like a default value that we set for the runner? It is. Okay. Let's have a yeah, let's just have current line, if it's 0, gets set to be the first line. So we can do that in eval. And honestly, we can just at the beginning of evaluation, we'll just set the VM to have the correct current line. So VM current line is -1, and then for each line in here, if the line here is less than VM current line, then VM current line is going to be this guy. And that'll just make sure it always starts at the beginning. Okay, assertion 0 and unreachable failed at eval C215. Right, and this is what do we do when we hit the empty statement? And we just break. Like that. So now we just have that spin loop that we did in bar.baz, which is the same behavior that we get in BW Basic. Cool. Great. Now what? I guess let's add trace, because why not? So that's going to be in Lexer H. We're going to have trace and no trace. If I go back to barbaz and we say 10 trace, illegal command after line number 10 trace. Oh, maybe it, so if it doesn't, if BW Basic doesn't support this, then I don't want to try to add it, just because we don't have a good frame of reference on that. Okay, what else do we have? Yeah, we've got like the display stuff that I don't want to mess with yet. See, like my biggest problem is that a lot of this stuff requires thought, like brain power that I don't really have right now. So maybe we don't do this. We could do 4. I don't think that would be too annoying. AXPER to AXPER. Step AXPER. So I guess start at number, end at number with an optional step. So let's see what that looks like. So 4. But wait, how do you basic for loop? That's gonna not work, is it? Yeah. For I to 10. Oh, and then it's got a next. Oh, I see. So next is the end of the loop. Yeah, no, because right now we don't even have like multi-line parsing. So I don't really want to deal with that quite yet. I know I'm being super lazy, but yeah, okay, you know what? Let's implement functions. I kind of forgot about these. We're not going to do any like user created functions. I don't even think those are supported. We're literally just going to add these numeric functions. I kind of completely forgot that these were in here. So let's see that. So A is sine of 0.5, and then we're going to say print A. So if I say BW basic on that guy, we get that number, sure. So now let's go back to parse.c. When we are, let's see what this looks like right now if we do our runner. Ooh, we have an issue here. That is because we need to go back to lexer.h and remove these. Okay, so unexpected character dot. Oh, do we not parse or lex, I guess, literals with dots in them? So is a digit. Do we do this? take number. F gets C if it's not, okay. So if it is not a digit, then we're gonna break. Do we have like A to D? Is that a thing? Like to parse a float. Function converts the initial portion of the string pointed. Yeah, I don't care. Convert a string to a double. Yeah, so A to F. Yeah, so let's say const char, not const, but char buff is 256, sure. And then size t buff len is 0. And then if we get a digit, rather than doing this, we're going to say buff at buff len plus equals 1. Or plus equals C, which is the character that we just read. If it's not a digit and C is not a dot, then we do this. And then here we're gonna say A to F over buff, and then buff at buff len is 0. Or I guess more properly, it's the null character, null byte. And then, yeah, so that's about it. We should also do a bounds check here. So if buff len is greater than or equal to, or I guess, yeah, if it's greater than or equal to 255, so we have room for a null byte, then we're going to say fprintf to standard error. Number literals may be at most 256 characters. And then we can also just do a bool has dot. So if we get a dot, has dot is true. If has dot is already set, then we can just say invalid integer or invalid number literal. And then honestly, we can just exit like that. Okay, and that should parse that correctly. Yeah, so now we get numlet 0.5. Okay. Eval C assertion postfix.count equals 1 failed. Right, because we're not parsing the function call. We're not treating it as a single value. Or not value, but we're not treating it as a single sub expression, really. So what we need to do is under, I guess, eval, if we get a token, or an ident, then rather than just appending it to the postfix, we need to peek the next token. So that's going to be token next, or I guess if I is less than expr count minus 1, meaning that we do have a next token, and, or I guess then we can say token peek is expr items I plus 1, so the next token. If peek kind is tk L parent, meaning that we have like foo, then what are we gonna do? So we want to, we want to consume tokens until we hit a closing parenthesis. However, we need to account for the case that we have like 1 plus sine 2 plus cosine a, in which case we need to balance these parentheses. And this very clearly becomes recursive. There's a bit of a weirdness here because we also need to support these parentheses existing. So let's see. Okay, so eval expert takes an expression and it returns a value. What does that mean? So when we're inside of parentheses, we can call eval expert again. The problem is we don't know when the end of the expression is. So we can do something like int or size t, depth is 0. And then the case where we get an L paren, we say depth plus equals 1. And then if we get an R paren, we say depth minus equals 1. If the depth is already 0, then what do we do? So in this case, we have hit, we're here. Or we have an invalid expression, to be fair. But we can figure that out in a bit. So like here, if we hit this R paren, then we can just return. So I want to keep this here, and we'll put a little dot there. And then I think that would be good. And then here, we have that, or that, or that. And we can say, what can we say? So peak kind is TKL paren. Then we're gonna take, oh, this is weird too. Since we're just looping over these, the expression is holding on to, it's an array, but we're slicing into that array, which is kind of weird. But we can say eval expr, pass in the VM, and then here we can pass in the a different expression, which is going to be count. Here is going to be expr count minus I plus 1. And then items is going to be expr items from I plus 1. No, I plus 2. And we're making a lot of assumptions that the data is just valid right now. And that's just a matter of... So capacity here doesn't matter because we're not resizing it. But I guess we can say expr.capacity. That's technically invalid, but it doesn't really matter. What now? We also need to pass the value, right? Except for the value, we're actually going to do value. We're going to just grab the value. And then I guess if this, if this return 1. What do you mean expected expression? Oh. Okay, cool. So now we're going to evaluate this expression using this. And this should be, like in this example, this would be this body. I think. That's what it should be. Yeah, and then once we have that, for now, let's return 0 and just printf and I guess both this stuff also goes down here. We're gonna print the name of the token, t value ident, and the inner value number. So we get sign of 0. So that's not quite correct. But it's not too far off. So do we have a method of printing expressions? If I go to the definition here, where are you? You're in parse. Parse print AST. No, but we do just loop over, or, well, I guess this isn't. Yeah, we do just loop over. So let's do that. So here, let's say printf, %s, where %s is t value ident. And then we're going to loop over the expression. So this is inner expert. And that's going to be this. Okay, and then yeah, we're just printing the standard out right now. And then finally, we're gonna finish this off with close bracket and then new line, like so. And then you're gonna be inner expert. So we get numlet, parent, and equal sign. What does this equal sign come from? Number literal, then the parent. I think we just have an off by 1 error here. So the count of the expression, yeah, because this needs to be, we want to skip the open. Yeah. So now we get sign of number and then 0. Okay, but why does inner value never get set? Right, because like if I were to just temporarily say inner value number equals 69.420, then we get that, yeah, that is the value that is held there, which means that this is never updated. Which is really weird. So we should be looping over the because this shouldn't be return 0. This should be like break. But it shouldn't break. It should, web developers are going to hate this. Go to finish. It's beautiful. Yeah, now we get sign 5, or sign 0.5. That is because we need to actually process all of the things that we've pushed onto the stacks and actually come up with the final value. Okay, so now we get sign of 0.5. And then now, I guess, yeah, we can get rid of... let's check with this like nested value. So 15b is this, and then let's print b. Oh shit. So we get sine is all of this garbage. Cosine is a. Okay. So the individual slices that we pass are correct. So sine contains 2 plus cosine parentheses in the n paren. Sine contains 2 plus cosine. Okay. And the cosine contains the a and the 2 r parens. Like that. Okay, that's cool. But then somehow we just infinite loop, which doesn't make a whole lot of sense. Like we're not that's not what the rest of the code does. Yeah, it just prints. So that's really weird. Cosine of 0 is... Why am I being stupid? Cosine of 0 is 1. Right? Yeah, okay. I feel like all of my high school and university teachers would be so disappointed in me. Anyways, yeah, what the hell is going on? So, cosine ends up with the correct thing, but it still gets 0 as the value. Right, that's actually okay. I guess I don't understand why this is looping like this. Like, it didn't do that when we didn't include these statements. Why does that print so many goddamn times? What the hell is going on? Oh. Whoa. That might be a bug. That's so weird. Oh, well, I'm also doing head n20, so it's just looping because duplicate line numbers. That's a bug. Okay. Great. Okay, so yeah, no, everything is working fine. We'll fix that issue in just a minute. Let's finish this stuff, though. So we have, we can get rid of all of this, I think. So now, depending on what function we're calling, we want to do something different. And so what we'll do is we'll just say like run function, takes in the name of the function, which in our case is going to be, oh fuck, what is it? T value ident, and I guess the argument. Do we have anything that takes multiple arguments? I really hope not. No, we do not. Hell yeah. Okay. So the argument here is going to be, I guess, inner value number. And then here, we can do go to append value, and that'll be here. Apparently I'm in like like really into really in a go-to mood. What the hell? I'm really in a go-to mood today. That is a weird sentence to say. double value. And then here we're going to say value is var value number. And then here we're going to say value is this. And then now let's create this run function. Can I? Okay, no, I can't. Like auto generate that. Double run function takes in a const char star function and double the arguments. So now we're going to say if stir case comp we're going to compare function with actually wait, so I do stir case comp elsewhere, yeah, and we put the literal here. So if we get sign, then we're going to return sign just sign of arg. And really, we don't even need else if here. We can do that. Yeah, and then if we get to the end, then we can say fprintf to standard error unknown function this. And then I guess really it would be even better to, what do we call this right here? Instead of doing a return value, we'll do like return whether we have an error. And then if we go back here, then we can say out. Oh, we still want to keep this arg. And then here we're going to say out. And I guess we still need to return. And that needs a star. And that needs an int return 0. And in C we can technically do something like this. No, I guess that's a statement, not an expression, so we can't do that. Never mind. I guess we could technically say return this because we have tuples in C, except they're not tuples and it's just a 0. But we're not going to do all of that because that looks horrible. Else if, and then I guess in this case we'll return 1. There. That seems to be a little bit cleaner. And then we can do that even. So we get sine, we get cosine, or I guess we'll go in their correct order. So abs gets us what, fabs, 8, I can vim, ATN for arctan. Also, what is this? Oh, I guess it's alphabetical because this is such a weird way to order functions. So this is arctan. I don't know how to. I assume that's atan. Yeah. Cosine is cos. Exp. Okay. Integer part of a number. That's not going to be a thing, but we can say int. And then natural log. Log. Natural logarithm. Okay. Arg. And then we have rand. Pseudo random number generator. If AX express positive, returns a random number from that. If it's 0, repeats the last result. Oh, God. Okay. So if arg is less than minus 1e6, so if we get a negative number, we're supposed to reseed, which is going to be srand. It takes an unsigned integer. Yeah, we're rewriting Chrome using a basic interpreter written in C. It's beautiful. Okay, so I think we're just gonna do a little bit of shenanigans here, because the seed value doesn't really matter. So we're gonna say cast this double to a float, and then we're gonna take a pointer to it. Then we're gonna cast that to an int pointer. And we're going to dereference that pointer. Oh, that's right. That's fine. I don't think we need to cast it to a float. And this will basically just treat part of the... Yeah, it'll just treat part of the double. Actually, we can use a long, which will use the entirety of the double. And then this still only wants an int. So let's say, what the hell am I doing? Long is, right, so we're going to take the n, and then we're going to shift it by 32, and we're going to XOR it with n, and 32, which is, that, except you can't do that in C. That. Is that right? So it's what? 1, 2, 3, 4 bytes. Yeah. Okay, cool. And then that, and we need a semicolon there, and a parenthesis there. Cool. So now we're seeding it when we get negative number. If arg is greater than 1e minus 6, meaning it's positive, then we generate a random number between 0 and 999, which is going to be, what is that? So this is rand divide by, or I guess rand as a double, divide by rand max also as a double. And then that gets set to be out. And is rand max, so this is just max end, that's kind of funny. Inclusive, so technically this is wrong because it can include the maximum. It won't, but it can. So how do we get around that? We have like a clamp F in C++. We do. It's, yeah, no, it's fine. We're not going to meet spec, but who cares? So otherwise, if we get 0, then we return the last value. And because thread safety is for Rust developers, and we're C developers right now, double, I guess saved rand is 0. And we're just going to write it directly into that variable. Thank you for all of the individual bits. Okay, so now we get rand. What else do we have? Sign. If let's copy this guy. Then what is this? This is sign SGN. Sign. And this is, there's a sign function in C. Yeah, sign bit. I really wish. Test the sign. Okay, great. What do you return? Macro returns non-zero if the sign is negative, otherwise it returns 0. That's not what I want. There's signum. Is that a thing in here? I mean, I don't, it really doesn't matter. I can very easily say x is less than negative 1e minus 6. We're being super proper with our floating point garbage. So if it's that, then we get negative 1. Otherwise, x is greater than 1e minus 6. Then we do 1, otherwise we do 0. And what is x? It's supposed to be arg. Okay. Oh, and these are all supposed to be else. Okay. What else? What else do we have? Sign. Nope. Sign is sign of arg. Square is the square root. Squirt of the number. And then tan is the tangent of the number. Okay, now let's, I guess, test and see if this stuff works. Postfix count equals 1 failed. Damn, you weren't supposed to do that. 1 plus sign of this stuff. 2 plus, okay, so it's parsing that, or I guess this isn't even really parsed. Let's see, let's printf run function, or not even printf, let's debug. Run function with this function with this arg. So we get run function sign of 0.5. I suspect we're just kind of messed up somewhere here. Let's go to append value. Debug append value. Wow, I really cannot type today. Then we're gonna append this value. So append value, that seems correct, that's fine. Postfix count equals 1. Okay, let's also check, is that an issue here? It is, so it's an issue always. Okay. Interesting. So we're asserting postfix count equals 1 here, which means that we have a single item left on the stack, which is the sum. So what is it in reality? So it's 2. We have 2 items left on the stack. That's mildly concerning. So for each item for this item, we get this value. Oh, right. So this is tokens. What is the tokens that are left? So we have Lex print token. Okay, so this is gonna be standard out. I guess standard error. It's gonna end up looking a little bit weird, but it doesn't really matter. It's debug output. So postfix items at I. And let's go ahead and give it a new line. Cool. So we get both this value and 0.5. Why is 0.5 ever on there? That doesn't make any sense. Oh. Okay, so right now we're evaluating this expression, or we're evaluating the inner expression, right? So here, or I guess, yeah, here, we evaluate this guy, but we don't actually consume those tokens. We don't skip that. So we, after we're done here, we just do that, which is obviously not what we want. Yeah, so we're gonna need to do something about that. I guess what we can do is we can just pass an I by reference here, which means that we can just use the same expression and make this hold on to I. I don't know what that colon was, but this is size Ti. Like that. Kind of weird, but it works. By pointer. Ordered comparison between pointer and integer. Right, so now all of these i's need to be dereferenced. Yeah, and so now these need to all basically pass I by reference, which is really annoying, but it's fine. C is just kind of an annoying language. Oh, too many arguments. What? Oh, that's eval AST. Okay. Okay, so now we got a segfault. That's very good. Yeah, you know what? Let's do some debugging. Makefile. Yeah. ggdb. And then let's main. And then I think we can gf2 this. Okay. If we run or not. Oh, we have to say we have to pass the file. Test baz bar. No. Bar baz. Like so. Why am I not getting a... This is really deep recursion there. Why am I not getting the decompilation? Or not even decompilation, it should just show the lines. can see the disassembly. I don't really want to do that. Why are you not showing me stuff? Make. Oh, did I not? What was it? Test, bar baz? No, bar bay. Yeah, there we go. Okay, so here is still not working. Why are you not working? So eval line 136 is where it's actually crashing. So yeah, it's in this function. We already knew that. Be really, really cool if you were. There we go. Okay, so this is just the call stack though. So it's not actually dereferencing anything here. This is so incredibly useful. Oh, wait, if you have unbounded recursion in C, that's a segfault, isn't it? I guess we can just call main directly. Yeah, unbounded recursion is a segfault. So let's see. Can we fix that? Why are we getting unbounded recursion? Where was this? This is in eval expr here. Oh, this should actually be I plus 2. Because we've consumed 2 tokens. Not that. I want to make that. Okay. Is that correct? So what is our statement? 1 plus sine 2 plus cosine of A, which is sine of 0.5. 1.251600. Okay. Cool. So that's surprisingly correct. Where else do we have this? You can go away. You can go away. And then we run this and we get just a couple of values, and both of which are correct. Very, very cool. Okay, now let's test some of these other functions. So if I were to say, also, since we have random numbers, let's go into main and do srand time of null. That's gonna need what time? Yeah. Okay, so now we're randomizing our numbers. Also, let's remove some of this logging. What is size equals printed? Size, yeah, this guy can go away. I kind of want to keep this. I like to see what the... No, we don't. I don't think we really need that. I'm going to just comment it out. There we go. Okay. So, I guess let's just test each of these functions independently. So if we go to bar baz here, we should be able to just say print absolute value of minus... oh, actually, we're not parsing that correctly, I think. So we do 42069. He's going to say it's an unexpected token. Yep. So let's go handle that. Here. So if we get under take number, where do we call this function? Here. So if it's a digit or... Oh, this is a little bit weird. Right now we only have addition. But we also need to handle like a minus prefix. But I'm kind of feeling lazy. So we're going to just say if is it a dash, and how do we get the next digit? Our next character? Okay, so we're using fgetC. That's fine. Yeah, so we'll just say else if is digit, or sorry, not that. If C is the dash and F gets C, no, not even that. Then we're gonna say char next is C, F gets C from what? From input. If is digit next, then we're gonna say unget C next. Is that, yeah, input, and then we basically just do this, and then instead of just saying num, we're gonna say minus num, like that. So we get 42069 correct. If we do the positive value, we get the same thing. If we do 0, we get the same thing. Okay. Next function is arctan. I'm not concerned about these ones. Integer part of a number. So int 42069. We get 420. Minus should also get negative 420. I don't know, 69, 420 gets us 69. Okay, that's cool. Now rand. So random of 0 should get us 0. Random of some positive number should get us a random number. Random every second. And then random negative 1. How do we even test this? Oh, I guess providing the same seed will give you the same... yeah, providing the same seed will give you the same value. So if we default to rand 1, or we use the default seed, and then we set it to negative 1, then we print rand 1, and then we print rand 1 again, we should get the same thing. So we should get 1 value, and then we should get 2 of the same value. Except we're looping because this bug is still here. 3, 4, 5. Okay, yeah, so we get 1 value, then we get 2 of the same. Cool. And then if we get rand 1, and then we say rand 0 several times, we should get just, god damn it. Then we just get a bunch of repeats. Cool. And then if we do rand 1 twice, that's really annoying. There. Cool. And then what other functions do we have in here? Back to eval. We've got log, I'm not concerned about that. Sign, let's just do a quick test over that. So 1 should get us 1, 0 should get us 0, and negative 52 should get us negative 1. And then just to confirm, 42 gets us 1 as well. Okay. Square, oh, this is wrong. That should be tan. Yeah, tan, and then unknown function. So if I were to say foo, unknown function foo, cool. Okay, let's fix this bug where I can put 2 lines with the same value. And it breaks like that. But before we do that, let's take like a 5-minute break or something, and we'll be right back. Okay, we're back. Yeah, so let's fix this, this bug. So basically the issue is that when you have two lines that have the same number, they just loop infinitely. I wonder if that happens if there's a space between them. So it does. Interesting. If I do 69 here, 69. It prints 69. That's so weird. Okay, that's fine. Let's look at that. So in main, when we run, we just call eval. So in eval, first of all, we get the first line, and then honestly, it doesn't matter. I think when we're parsing the lines, previous line, we need to just ensure that all line numbers are increasing, strictly increasing. Which looks like we already were doing. If prev line is greater than or equal to the current line, then we do invalid line number. But this does not seem to be working, because we're not updating the previous line. Yep. Okay. Prev line is line.line. Great. Well, that was an easy bug to fix. Very happy to see that. Okay. Yeah, I guess we can just get rid of this. And yeah, that's, I guess we have a basic interpreter. Let's write a quick readme. This is a basic interpreter. Interpreter. That is a hard word to type. Build. Make. Fantastic. Run. Dependencies. libc. That's it, right? Yep, libc. Great. Okay, and then let's add some references. So this, for sure, I don't really count that because we never used that. What was the other basic thing? I don't have it on there. Let me check. I don't have it on there either. What? Maybe there wasn't even anything else, and I'm just making it up. That does sound like me. Okay, so yeah, that seems cool. We've got this. We've got this. We can remove foo and foo.c. And finish. Or I guess, yeah, finish. Let's go back. Let's actually rename this test as well. Foo to be not fizz. It's fib. And we can remove bar. That doesn't even have anything in it. And the fib.bass looks like that. Cool. Finish fib example. Cool. So now it's pretty much done. You can grab it from there. And I think that's going to be it for today. So thank you guys for watching, and I will see you next time.